You should be on page 47 of your notes. What's in the top box? Let's read that together. A number that is in scientific notation takes on the form of a times 10 to the n power, where a is called the significant figure and is greater than 1 but less than 10, and n is an integer. The number after the x, or the time sign, or 10 to the nth is called the order of magnitude. So the two important things to pull out of this paragraph is this significant figure is this A. And the other thing that you need to pull out of here is this power of 10 is called the order of magnitude. It's a lot of words for just saying that. All right, so let's talk about how to get, first of all, when we use scientific notation. Scientific notation is used to manage really, really large numbers and really, really small numbers so you can compare them or do computations with them. So first we're going to talk about really big numbers and how to change them into scientific notation. So first of all, we have numbers that are already in scientific notation because here is your significant digit, here is your order of magnitude. So we're going to change those to be regular numbers, okay? So what you're going to do is you're going to take this decimal right here and you are going to move it right the same number of places that the exponent is. So we are going to take 6.345 and we're going to include the digits here. We're going to move over 8 spaces to the right. 1, 2, 3, 4, 5, 6, 7, 8. And we're going to fill in with zeros. So you should have 8 digits after the decimal. The decimal's moved over to the other side. So we have that's your number in standard form. That's a really big number. So let's look at B. Here is your significant digit. Here is your order of magnitude. This 4, it's positive, so you're going to move to the right, tells you to move your decimal over 4 places. So we're going to go 1, 2, 3, 4, fill in the rest with zeros. So we have 80,400. E, here's your significant digit. Here's your order of magnitude. This tells you how many places to move your decimal to the right because it's positive. So 1, 2, 3, 4, 5. We're going to add 3 zeros. So we have 426,000. On the other side of the page, we're going from standard notation, which is the numbers that we see every day, to scientific notation. So our decimal is here, even though we don't see it. So we are going to count the spaces that it takes to move that decimal over until there is 1 digit to the left, which is greater than 1, less than 10. So we're going to go 1, 2, 3 places. We're going to make that 5 and 32 hundredths times 10 to the power that we moved. We moved 3 spaces, so that's 10 to the third. Here is my decimal. We need to move all the way down till there's one number to the left. 1, 2, 3, 4, 5 spaces. So I have 4.2 times 10 to the fifth. You don't have to put the zeros in there, only the other significant digits. All right, look at this number. We're going to start way down here, and we're going to go until there is one number to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9.04 times 10 to the 9th power. So these were all really, really big numbers. Let's talk about some really small numbers. When they're small numbers or decimals, you'll see that they have a negative exponent. So let's change 4 and 2 tenths times 10 to the negative 8th power to standard notation. We see that this is a negative exponent, so we know that it is going to be a decimal. Okay, so we're going to move this over here. We have 4.2. It says we need negative 8 spaces, so we're going to go to the left. 1, 2, 3, 4, 5, 6, 7, 8. We're going to fill in with zeros. Tiny, tiny number there. The next one, letter B, says 8 and 1200ths times 10 to the negative 7th power. We're going to start negative, so we're going to go this way and go 7. Fill in the zeros. Okay, C, also a negative exponent. So here's our number, and we're going to move to the left 3 spaces. And there's our decimal. Okay, to go from standard notation to scientific notation, we're going to move to the right. So this, we're going to count how many spaces it takes to get one significant digit to the left. Not a 0, it has to be greater than 1. So 1, 2, 3, 4, and there's one digit to the left. So we have 7.5 times 10 to the negative 4. Again, we're going to do the same thing. 1, 2, 3. So we have 4 and 5 thousandths times 10 to the negative 3rd. This last one, we're going to keep going until we get one digit to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 9 and 2 tenths times 10 to the negative 10th power. All right, let's do a couple more. Number 3 says, express 4,532,344 in scientific notation with 3 significant figures. What that means is we're going to cut that number off after 3 figures. So let's do this in scientific notation. Let me rewrite it. Okay, so here's our decimal. So 1, 2, 3, 4, 5, 6. So I have 4 is one digit, 2, 3 times 10 to the 6th power. Okay, so we cut all these off, and these are our significant digits because it tells us only use 3 significant digits. Okay, so number 4, we're going to express that number in scientific notation with 2 significant figures. So this is a decimal, so we should have a negative exponent. So we're going to move our decimal 1, 2, 3, 4, and it says 2 significant figures, so it's going to be 1, 2 significant figures times 10 to the negative 4. All right, that's all we have.